Hi, I'm Paul Germain. Welcome to another session of Smart Boating. As you know, if you watched the show before, we cover a wide variety of topics from man overboard to marine insurance. And the whole idea is to give you some information that will help you make smarter decisions and have more fun on the water. Today, this show is kind of right up that alley. We're going to talk about boat design and boat kits. We're here with a very knowledgeable person. His name's Clint Chase, who's the president of Chase Smallcraft. Welcome, Clint.
Thanks. Good to be here.
Great to have you. Really interesting show here today, talking about boat design and boat kits. But before we get into it, can you share with people a little bit about your background in boating?
Sure. Well, I got started doing all this kind of with the inspiration of some old friends and family. And they introduced me to old plastic boats, and I started fixing them up. Mm-hmm. And one thing led to another, and somebody said, hey, you should try building a boat. Oh. And so I started building a boat and said, this is really exciting. I love this. Okay. And it kind of brought out, I think, the blood in me, which was about building. And then that led to design, because I felt like I wanted to learn how to design a boat.
Right.
And one thing led to another. I went into teaching and changed careers and decided to combine the two and started teaching with boats, and eventually kits came up because I thought it would be a great way to teach.
Okay.
And so the kits kind of took off. That's where people's interest was, and that's where I put my time, and then the business evolved from there.
Mm-hmm. Interesting. So you've got a lot of experience in this area,
yes.
Small boat design and boat kits, so why don't we get right into it?
All right, sounds good.
Great. Well, Clint, this whole topic of boat design and boat kits is a large one. We can't cover everything today, but we can cover a lot of important details, I think. And perhaps we could start with your vision and your mission or your methodology of approaching that.
Mm-hmm. Well, the vision is to essentially bring to people's lives the ability to build these boats themselves, mm-hmm. And to learn how to build them. And so get them into these small boats, from getting a kit to build themselves, the help they need along the way, to the help to learn how to use them on the water. Right. And so I do that by having a sort of a big catalog of kits with mm-hmm. lots of offerings, mm-hmm. and then those kits are complete. They're every soup to nuts, everything somebody's going to need, right. Really kind of becoming like a one-stop source for that boat. So if they really love a particular skiff, they can get everything they need. Mm-hmm. And then, but sometimes they're a little hesitant to jump right in because it's a lot, it's a big project. Yeah. And so, how do you do this? How do you get started? So that's where the teaching comes in. Nice. So I offer the workshops. People can come in and learn how to build this boat, and then they go back home, sometimes with a kit, because they've got that sort of confidence and competence to take it on. They
know how to do it now. Okay. Yeah. All right. Great. Yeah. All right. So you're trying to get everyone out in the water, and you're trying to teach them and give them some kits so they can participate themselves in the process. Yeah. Okay. Great. Well, let's. You've got a portfolio of kits, if you will. If I understand, you get rowing craft, you get sailing craft, you get outboards. Those are the three main sections. Yep. Can you show us a couple photos, just quick representatives of the different types?
Yeah. So here we have, this is the Echo Bay Dory skiff. It's a 12-foot skiff, mm-hmm. Row and sail. It actually happens to be one of the first kits I did, and one I teach a fair bit with. As you see with the kids in here, these guys actually built this particular boat. Oh, really? This is down in Mystic during a boat show down there, the wooden boat show. Okay. So we got the Echo Bay Dory skiff, 12 mm-hmm. feet. Okay. That's a rowboat or a sailboat. This is a more serious, if you will, rowboat called the Drake 17. Mm-hmm. Kind of pleasure rowing, seaworthy, a boat that somebody can really get out there with. Somebody who's a little bit more serious about rowing, they're going to be interested in a boat like this. This is based on a style of boat called a fairing in Norway. Mm-hmm. This is one of the more popular rowboats, along with the Echo Bay. Mm-hmm. with the rowboat line. This is actually just an enlarged echo bay. This is a Caravelle, so a little more capacity. This is a boat that 2 people could row together, so tandem rowing, and it's a little bit more stable than an echo bay. Get more people in there, kids, what have you, pets. People use this as tenders for boats too, for larger boats.
All right.
This is another one of the more serious boats, like the Drake 17, but sportier, faster, lighter, a little more performance-oriented. People can put fixed seats or sliding seats in these boats, depending on how they like to row. Right. It's a very physical sport, so everybody has their particular preferences. So those are representations of the rowing craft.
Okay, all right.
In the sailing line, this is, again, the Echo Bay Dory skiff, but this is a rowing model. It's actually the same boat. It's just rigged for sailing. It can go both ways. These guys could come into the dock, take the mast out, and start rowing if they wanted to. This is the Caravelle, again, like the rowing model, but more specific to sailing. This is a really nice boat. It's got good capacity and stability for sailing. A lot of people sail this boat, and some people just take the same boat and rig it for tandem rowing. So that makes these boats fairly versatile. This is a little bit more sailboat oriented. This is a 16-foot Calendar Islands yawl, and in this particular case, it's rigged with a mizzen. And a lot of people use this for camp cruising, day sailing, that sort of stuff. The lug rig doesn't have any stays, so this mast just lifts in and lifts that out, and is easy to manage. A lot of the boats have this rig. It's a popular small boat rig. This is the Goat Island skiff, another popular, it's about the same size as the Calendar Islands, but lighter and sportier. This particular one is also rigged with a mizzen, but it doesn't have to be. That's the Goat Island skiff. And then the last kind of representation of what we got for sailboats, this is the biggest one. This is a cabin day sailor called the Jewel, designed by Francois Vivier. And the sail's not up in this picture, but you can get a good picture of how beautiful it is. It's beautifully designed. It's got a cabin. People take this weekending, so they'll camp out on the boat and really kind of camp cruise and go places. Yet it's trailerable, so they can bring it up and down the coast. This is an example of one of the outboard skiffs. This is a Bayview 13. And another outboard skiff, the first in the line that we created was the Compass Skiff 10. Also used for teaching quite a bit. A lot of kids and adults and grandkids get involved in building these boats. Just a small, fun outboard skiff, fishing, puttering around, picnicking, and that sort of thing.
Wow, that looks like a fun little boat.
Yeah, it is a lot of fun.
Well, Clint, that's quite a portfolio of boats. Maybe what we could do is help people understand the creative design process by following an example or two through that process.
Yep, sure. Here is the Compass skiff. It's a 10-foot skiff that I sketched on paper. And what we're seeing is a decent sketch of that, nothing too fancy, but not super rough. And this is actually imported into Rhino, which is the 3D CAD software I use for all the design and all the CNC cutting, for that matter. And so we see the sketch here brought in as essentially a backdrop. And over this, I can start sketching actual lines that will become a hull surface of the boat. So we're two-dimensional right now. And what I'm going to do here is I'm going to trace a couple curves. I'm going to trace the shear. I'm going to trace the bottom of the boat. We call this the chine. And this is the profile view. And I'm also going to trace the same lines here. There's the shear and here's the chine in plan view. So I'm going to trace these out. And it's literally clicking and dragging and making points that represents the boat. There's the shear curve in profile. I'm going to go trace the shear curve in plan view. And when this is done, it could be done very accurately, very carefully, but we're going to rework these a little bit too, so we don't have to go super crazy. There's the bottom of the boat, in profile, or the chine, as we would say. So we're going to trace that out. So there's the chine and profile. Now I'm going to trace that same curve as this right here that I'm tracing
I
out, just
see.
in plan
Okay.
view. Think of it as the bird's eye or the
Bird's
fisheye view
Okay.
of the boat.
Yeah.
So what we're seeing in this view here are widths out to those curves. If I were to take a measurement, I would take a width
Right.
out to that curve. That's the chine. That curve could be taken as a height relative to a line in this view. So those are the shear curves and the bottom curves. Now what I can do is zoom out here. This is what we call, I'm just going to change a couple things here so that everything's visible. So what we have here, what makes Rhino special is that there's 4 views.
Oh.
I've just traced this in the top bird's eye view.
Yes.
Okay, so here's the perspective view. And so now I'm going to actually turn off that sketch because I don't need it anymore.
Okay.
All right, and I'm going to rotate these two so that it shows up. Okay, so now these lines here are the lines I just rotated.
Okay.
And so now I'm already starting to get 3D. So now what we're going to do is I'm going to make these curves truly 3 dimensions.
All right.
All right, so I'm going to go ahead and start putting in some commands here to Rhino that tells it what I want it to do.
Okay.
Called curve to view. And so what it's going to do is it's going to take these input curves, so the shear and the shear, and make it into this, what you see here is a 3-dimensional representation. So there's the 3D curve right there.
Okay.
That's the same curve, okay, for the shear. So now I'm going to do the same thing again for the bottom or the chine.
Yeah.
All right. And I'm going to turn off those curves. So now we see, let me just get that back here. Okay, so I'm just turning off layers that isolate what I want to see.
I see. Okay.
So
narrowing it down.
Narrowing it down. So I'm going to go ahead and make this into an actual plank surface, the actual side of the boat.
Okay.
These can be reworked and rejiggered however I want, but once I have that, I can actually go ahead and create this. Really, it's a 3-dimensional surface of the boat.
Wow.
All right? And I'm going to mirror that over. Do that over here. Oh, this is not working.
Okay.
So let's get this.
Other side of the boat, I guess.
I'm just gonna. We're just gonna do it this way. All right. So there is this other side of the boat.
Oh yeah.
All right. So now you can start seeing what's happening there, and I could actually make the bottom.
Yeah.
There's a lot of commands to do that, and I'm just going to choose this one here that shows the bottom of the boat.
Wow.
And so now you can start making out what's happening here. We've got the sides, got the bottom, and
Flip
then
it all around. Look at it from different angles.
Yep, and that's one of the things that makes this particular software pretty powerful is the ability to visualize in 3D. So now I'm just making the transom, and we have a three-dimensional model of the boat. We started with 2-dimensional curves, went to 3-dimensional curves, and now we have these surfaces that is the hull of the boat.
And what can you do from this stage? So you've got the hull of the boat. That's quite a distance from the sketch, to be sure. But is there another important element that this can give you in terms of information? Yeah,
well, so now what we can do is start deciding design-wise, will this boat hold the number of people we want, the volume, the capacity, surface area, all of those specs.
Okay.
So a separate model is created for that. I call it a hydrostatics model. You know, you could see these curves, it looks a little sweet, right? So I've reworked those curves. I kind of jumped through it pretty fast, but these surfaces are really nice. The boat's looking really good. And so in Rhino, this is considered a watertight surface. So when I click on it, everything is joined. You can see everything is one shell. And when I do that, I can ask Rhino to generate hydrostatics report. And literally, I put in hydrostatics. I tell it what I want the waterline elevation to be, where the waterline's going to be, and it reports back to me volume of displacement, which becomes how many pounds of gear, people, and
what it can support.
Surface area, the center of buoyancy, wetted surface area, all of these important elements. And I can decide to go back and tweak the 2D and come back to this again with better numbers depending on what I like. If I need more volume, I can just make decisions based on this information, and that's what we can get.
That's neat.
Yeah.
Well, Clint, designing a rowboat is not simple, but it's simpler than some other craft. When you get a sailboat, you get some different forces to encompass in your thinking.
Yes, yes. So here's a 18-foot sailboat. The Calendar Island's 18, and so we have the sails in here. Here you can see the centerboard and the rudder. All of the spars are modeled, and so it gets pretty complicated. But you know, it's really an iterative process. This is drawn, and really where the time is really modeling all of the parts and pieces and how they fit together. For example, downstairs, I'm going to be showing everybody how we cut some of these parts out of hardwood. And really it's making sure it works here on the screen and in the computer. And if it's done right, it works on the shop floor as well.
Okay, that's the key.
Yeah.
All right. Well, that's an interesting process. Let's talk a little bit more about the kits.
Sure. Well, it's a fairly involved process, but with a little bit of time, we can actually model some of the features that are CNC cut and are part of the kits. Here we see little tabs sticking out. Those aren't left there, don't worry. Those are cut flush later when the boat is built, but these are little locator tabs with slots that are in this side panel so that all of this structure on the inside can be located properly. And that plank is actually unrolled, and we go back to 2D. So this is now the 2D representation of that three-dimensional hull side. And you can see these slots. That's where the tabs go. These are scribes. They're markings that allow people to put where the seats go. And what we have here is actually the joint. See, these panels that are cut out are only 8 foot long. So we have to have what's called a scarf joint there so that they can join one 8-foot piece to a smaller piece to get the actual length of the boat. So that's called a cutting file. We're getting into 2D again, and eventually this can be programmed and cut out of the wood.
Okay.
Over back at the sailboat line of things, we can actually get into some pretty cool stuff. So we're doing a lot of three-dimensional milling versus just two-dimensional milling, like getting the 3D surfaces of this fairly complicated NACA foil. That really makes a sailboat go nicely. And some of the hardwood components here that are shaped on the CNC machine are modeled here, and we'll be cutting those. Those are also created cutting files, and then we're going to cut those out in the CNC as well. So those are all kit components that are modeled, made 2D, and then programmed to cut out the actual wood which goes into the kit.
And we'll see those downstairs in the wood shop.
Yes, we will.
Yes. Well, Clint, a kit boat's no different than a boat built at the local boatyard. It uses a variety of woods, different woods for different applications. This is a piece of pine.
Yep.
Where's that used?
A lot of seats, especially because I can get them wide like that.
Oh, okay. All right. And then this is spruce, right?
It is. Spruce. The spruce we get is used for masts and spars because it's light and it's strong. We bring it in large quantities. In fact, this pile behind us is mostly spruce.
Really?
We dry it here, we cure it, and we put it into masts and spars for the boats.
Oh, okay. All right. So a very different application for this wood as
Totally
opposed
different.
to the pine.
You got it.
Right. This is cedar. I remember one of my first boats had a lot of cedar and very rot resistant, right?
It is. It's soft, but it's really rot resistant. So in a lot of traditional boats, it's used for planking.
Yes. Yes.
Our planks are made out of plywood cut on the CNC machine in the kits, but where we use cedar is in floorboards. Some of the parts that we want to bend easily, we'll use cedar.
Oh, yeah, right,
but a lot of
right.
floorboards and chine logs typically are coming out of cedar.
Cedar, yeah. You've got some hardwoods there?
Yeah, so One particular hardwood that we like is white ash. It's very dense, really good for gunnels. It bends well, it glues well. It's not particularly rot resistant, so we wouldn't want to use this on a keel, for example.
Right.
So we're really looking at the characteristics of the wood and using them in the right place.
Okay.
This one is mahogany. You can see it's much darker.
Very dense.
It's got a beautiful grain pattern, so it could
Yes.
be decorative, but it's structural, it's dense, glues well. We have 3 different varieties we use for different applications, but they have this nice rich brown color. It looks really beautiful under varnish.
Okay, so the right wood for the right application.
Yeah, absolutely.
Well, Clint, the first step in the process is once you select the correct wood, you've got to basically plane it down to the correct size, correct?
That's right. All of the parts are going out to the customer 2 dimension, thickness to width, with a little bit of extra length built in. So the first step is we're going to plane this wood down to the required thickness, then we'll edge it, and then we'll rip it to the width we need.
All right, well, let's get going.
Okay.
Well, Clint, this is another piece of machinery you use to make the kits come together. What is it and how does it work?
This is a jointer, and usually after planing, I'm going to joint this edge, which will make it straight and square, and then it's ready to rip on the table saw.
Okay.
So we'll go ahead and do that.
Well, Clint, you have to take a lot of time here in the shop to make sure that the pieces you send out are consistently accurate, right?
That's right. We don't want everybody at home to have to buy these machines. So everything's going out at the exact thickness, the exact width that they need. This board is going to be for cleats. It's going to go out a little bit long, and the builder at home trims it to length. So whoever's cutting needs to make sure that those dimensions are really accurate.
Yes, okay. Well, why don't we fire it up
All
and
right.
show them how we do it.
Here we go.
Clint, solid, leak-proof joints are an integral part of having a good boating experience.
Oh, yeah.
Can you show us how you handle that here with the kits?
Yeah, sure. Well, this is actually, we're seeing what I call an NC scarf. So if you're building this boat at home, Paul, you're going to get this plank pre-cut exactly to shape. And I have to make sure you have a way to reestablish that shape really accurately, because that determines the shape of the boat.
Yes.
And so this scarf joint is interlocking. We're going to glue it with epoxy, which is very strong and waterproof.
Yeah.
And the next day we take the clamps off and we can actually bend this plank to make the boat.
Wow.
So what I have here is epoxy, specific kind of epoxy I like to use, and it's painted right onto the wood. And the key part of doing this process is that all the little nooks and crannies is covered with glue.
Okay, with the epoxy.
With the epoxy.
And normally they do this down on a table. We're just showing it so they can see it easier at
home.
Yep.
This is flat on a bench. Some of the kits actually have a long strong back. That's part where the molds are set up and the boat is built over that. And they can actually use that as a bench.
All right.
So sometimes the bench is in the kit even. And so we spread this glue like so.
Yeah. We're going quickly here today for the sake of the show.
Going quickly, but I'm making sure all the little nooks and crannies are covered. And then we're going to put this together.
Okay.
Like so, and it interlocks, and so you can see when I shake this end, your end is shaking. So now we have it interlocking, it's pressed together, and it's flush.
Right.
We're getting a little squeeze out here, which is important because that tells us that plank is glued together properly. And then we're going to put that flat on the bench, cover it with what I call a caul that disperses the pressure, and it gets clamped down to the bench with a couple clamps, and that's it. And it stays like that for a day, and the next day, this is rock solid.
Beautiful. Well, Clint, to ease the boat building process, CNC machine can come in very useful to creating consistently good parts, right?
Right. What we have here is we've got the cutting file opened up of the part we're going to cut. We're going to do one example part here. So this is created in the office of the designed part. It's opened here, and the machine is going to follow the instructions that's created here in the form of G-code. And it's going to cut the part out of the material here, and then we can look at it when we're done.
Beautiful. And you've got another control right there, huh?
Yeah, so this is the part this is the controller for the actual machine. It's the instruction pad, essentially.
Okay, all right.
So we're going to go ahead and cut this part out. It'll make a little noise.
Okay.
And then we'll take a look at it.
All right.
Okay, and there's the part.
Little tabs.
These little tabs just make sure it doesn't move on us while it's being cut. This is not a boat part, but it's used for building the boat. It happens to be a clamp of sorts. Right. And there's our part, and these get loaded into the kit.
Excellent. Well, Clint, when you get everything together, you've done all the design and the machining, everything, it all goes into the kit. And this is a fairly complete kit, isn't it?
It's really complete. So people are getting all of the wood cut, solid wood, plywood, any other parts that are wood come in the kit, the epoxy to glue it all together, the hardware to fit it out and trim it out, and the instructions that make it go together. And there's some other parts. People can get oars, sails, everything goes in this complete package. It gets wrapped off and shipped off on a big truck.
Off it goes.
Yep.
And then it's as easy as pulling it apart and
they pull it together, and one of the first things they do when they get it is they glue that scarf together and prep some of the other parts, and then start with a manual and work right through it and start building their boat.
Beautiful. Well, Clint, this is a finished out 12-foot Echo Bay.
Yep.
And you can see how nice it is, the different woods, the pine and the various woods and finishes here. There's a couple of design details we wanted to come back to revisit, right?
Yeah. Yeah, one was that scarf joint we saw earlier being glued. At the end of the day, when the boat's built, this is all we see of that scarf is this wavy edge. Okay, so that's actually the scarf joint, gluing the two panels together in the boat, locked in forever.
Beautiful.
Another element is, we mentioned earlier, the tab and lock system. So what we're seeing here is this is the actual tab and lock, okay? This would represent the bulkhead or the frame. This would represent the plank. The tab locates to the plank like so, okay, and locates very precisely because this is a tight fit. And then temporarily this wedge is put in. After the glue is cured, this gets cut flush. When the boat's painted over, you never see that on the outside. From the inside, it's locked inside the glue joints, so you don't actually see the tab there either. And it's proven to be an excellent feature on these kits.
Helps make them go together more consistently, more easily.
Yeah, it really makes it fun and easy and something anybody can do.
Right. Well, Clint, we've covered a lot of ground today on the design and the build of kit boats.
Yep.
And whether it's the materials used or the process, the machinery, there's a lot of stuff that goes into it. Is there anything else you'd like to add before we close out the show today?
Well, I think I'd just add that one of the joys we get here is seeing people jump into this project, and find a boat that excites them. And one of the joys we have is helping people build those boats, whether it's in a class or just helping them along at home building it, and providing the instruction they need, answering questions, seeing that boat hit the water, and it's a continuation from there, helping them rig it and use the boat, and how do I trailer it, all of those things. It's a big package, and that's what we're really all about here at Chase Smallcraft.
Okay, and if they want to reach you, do you have a website?
Yeah, they can see all the boats at chasesmallcraft.com, and there's all the models listed there, what goes into the kit, and they could always reach out, and they can always ask us questions about any of the boats, or just in general, how do I get into this? What's the best fit for me? What's the best design or the best complexity for me to get into?
All right. Well, thank you.
Well, thank you. It's been really fun.
Good, good. And thank you, Smart Boating viewers, for joining us. If you have any comments or questions, please join us on our website, www.smartboatingus.com. Thank you.